variance of a sample and a population. The variance of a set of value is the measure of the variation, which is equal to the square of the standard deviation. If you have a standard deviation, you square it, and that's your variance. When it's for a sample, we use standard deviation as S, and then we square it. For a population, we use sigma, and we square it. That's all that this is doing, is taking those values and squaring them. And here's the notation. So S for sample standard deviation, S squared for sample variance, sigma for population standard deviation, sigma squared for population variance. We're comparing variations in different samples or populations. It is a good practice to compare two sample standard deviations only when the sample means are approximately the same. Compare only when the sample means are approximately the same. When comparing variation in samples or populations with different means, it is better to use what we call the coefficient of variation. Also, we use the coefficient of variation to compare variation from two samples or populations with different scales or units. Different scales or units of values. What if we wanted to compare miles per gallon to weight of a car? If I did that, I could say the units for gasoline consumption would be miles per gallon. The units for weight of a car, it's pounds. These are called units. Miles per gallon is units, pounds is units. If we're going to compare things that have different scales or units of measure, then we would again be more likely to use this coefficient of variation, such as a comparison of variation of heights with men with heights of women. Again, they're going to be different, even though they have the same units. Here is the formula, and we're not going to really use the formula. We're going to use Statcrunch. Question 1. Listed below are prices in dollars for one night at different hotels in a certain region. The range, variance, and standard deviation for the given sample data include appropriate units. We talked about units in the results, and how useful are the measures of variation for someone searching for a room. Notice I have my box here that I click on, and I'm going to open this in Statcrunch. So we just got the numbers from this problem, and now I want to find the range. We want to find the range, the variance, and the standard deviation. I'm going to click here to Stat, Summary Stats column. Select var 1, and I always like to have the number. I need the variance, I need the standard deviation, and I'm holding down the control key. When I do the first number, I don't. Then as I want to add more and more variables, I hold the control key down, and then more than one will go in. Standard deviation, and we want the range. And let's do min and max so we can see how the range is being calculated. Let's compute. And now I have all my information. The range, if I have my max minus my min, I get 8,6,168, which is exactly what it's giving me here for my range. I don't need to do the math, but I wanted to show you that that's all that they're doing. The range is 168, and here they want to know what the units are. It's 168. And here it says listed below are prices in dollars. So it's $168. Perfect. The standard deviation of the sample data is, and we want to do it to one decimal place, we're going to have to round that to a 3 because the number after the 2 is an 8. So this actually gets rounded up 2 or 3, and our standard deviation is in dollars. And then the variance, which is the standard deviation squared. The 8 is next. That last number is going to be 0.8 instead of 0.7. And because the variance is the standard deviation squared, what our units are going to be is dollars squared. How useful are the measures of variation for someone searching for a room? The measures of variation are not very useful because when searching for a room, low prices, location, and good accommodations are more important than the amount of variation in the area. There's a range of $168 between the cheapest room I can find and the most expensive room I can find. The quality and the level of the hotel that we're staying at could be different. I'm going to say A, but let's read them all so we can see whether or not they make any sense. The measures of variation are not very useful because the values are nominal data. Remember what nominal data was. Nominal data was values that you could put in order, but they didn't represent counts of anything. And dollars definitely represent counts. So nominal data is not the answer. This is not nominal data. This is actually values that have meaning. Nominal would be more like the numbers on the back of a football player's shirt. They're numbers, but subtracting 2 of them or adding 2 of them or taking the average doesn't make any difference. The measures of variation are very useful because a person does not want to buy a room where the variation is too high. Well, I don't think that's true because we all know that different hotels are going to charge different prices. We may not want the most expensive, but we may not want the cheapest. And the measure of variation are very useful because a person does not want to buy a room where the variation is too low. Nothing to do with picking a hotel. I think it's A. Let's check. Okay, we got it. There we have it. I wanted to show you how Statcrunch can help you. The coefficient of variation for the pulse rates is listed below are pulse rates from samples of adult male and females. Does there appear to be a difference? Find the coefficient of variation for each of the 2 samples, then compare the variation. I'm clicking on the box. I'm opening it in Statcrunch, Summary Stats columns. Pick both. I'm going to hold down the control key to get the second one. Again, what do I need? The coefficient of variation. There's my data. And it says the coefficient of variation for male pulse rates is, and this is giving values in percents. So for males, and we want to round it to 1 decimal, 17.3%. The coefficient of variation for females is 10.3 to 1 decimal place. Check our answer. And now it wants us to compare them. The coefficients of variations for each data set are more than 5 percentage points apart. They're 7 percentage points apart. 17.3 minus 10.3. They're more than 5. Therefore, the male pulse rates vary significantly more than the female pulse rates. There's more variation in male pulse rates than in female pulse rates. But there's more than 5 points. That's a big difference. And we check our answer by the rule of thumb estimate. And if you remember how to do the rule of thumb estimate, the standard deviation is approximately what? So the rule of thumb, we want to find the range S is approximately the range divided by 4. Notice how hard it is to find the range because we have so many numbers. We don't want to look through all these numbers, do we? So instead of doing that, we're just going to go here to Summary Stats columns and var1. And really all we need here is the range. All we really need is the range. We hit compute. The range is 5. This is equal to 5 divided by 4. And in decimal, That's 1.25. If you're not sure how to do that, you would do 5 divided by 4 on your calculator. Check answer. Compare the results to the actual standard deviation. I can just go right back up here and hit Options, Edit. Now they're asking me about the real standard deviation. We can put the standard deviation and the range both together. And then I hit Compute, and now I have both pieces of information. The estimated standard deviation is, well, estimated, if I rounded to 1 decimal place, would be 1.3. So it is within 0.3 of the actual standard deviation. Thus, the estimated standard deviation is not significantly different than the actual standard deviation. And those are the 3 questions that I did pick out for us to do